Assalamualaikum warahmatullahi wabarakatuh. In this video, I would like to discuss flexibility method for trust. And flexibility method in the textbook is called as force method. Okay, to analyze, we use a flexibility method to analyze indeterminate structure, indeterminate trust. Where in trust we can have redundant, from reaction as well as member force. Okay, let's look at this. Degree of indeterminacy of trust can usually be determined by inspection. However, if this becomes difficult, we have to use this equation, B plus R minus 2J. Okay, we also call as this is how we analyze degree of indeterminacy. It is M plus R minus 2J. Okay, this is for member. M is for member, R is for reaction, and J is for joint. Okay. The unknown are represented by the number of bars, forces. So this is M. This is also M, members. R is support reaction, and J is joint. Okay. So example 10.7, determine the force in member AC. Determine force in member AC. But before we analyze this, I would like to explain about two condition of indeterminacy, degree of indeterminacy in trust. There are two conditions. One is called as externally. One is called as externally indeterminate. Externally indeterminate trust. And another one is called as internally indeterminate trust. Okay, in what condition we call the trust as externally indeterminate, and in what condition we call the trust as internally indeterminate. Externally indeterminate means that redundant from support. When redundant come from support, we call as externally indeterminate. But there is a case where redundant is come from member force. Member force is internal forces. Member force is internal force. Member force is internal force. So there is a case where redundant is member force, where we need to remove member from the system. If it is externally indeterminate, as usual, we have to remove reaction at the support. But if it is internally indeterminate trust, we have to remove member force. Okay, so let's look at this example given in the textbook under example 10.7. Example 10.7. Okay, determine force in member AC. Determine force in member AC of the truss. Okay, so let's check. Okay, Okay, don't worry about the unit, because we want to focus on the value only. Okay, so by calculating the degree of indeterminacy, it is M plus R minus 2J. Okay, we have how many members? We have 1, 2, 3, 4, 5, 6. 6 plus reaction. Reaction, we got one pin here, one roller here, so we get 3. And there are 4 joints. 2 times 4. So total is Total is 1. Total is 1. And we have to check as well the stability. The stability. Okay, the truss is stable whenever it has one pin and one roller. One pin, one roller. So in this case, okay, there is one pin, one roller. So having this, because we cannot remove, because there is one pin here, this and one roller here. So minimum unknown reaction for stable structure must be 3. Minimum unknown reaction to get stable structure, stable truss is 3. Means that even though the redundant is equivalent to 1, we cannot remove 1 from reaction, because if we remove 1 from reaction, what we get is 2 unknown reaction in the truss, so the truss is unstable. So having this condition, what we should do is we have to remove member as redundant. We have to remove member as redundant. So we should remove member as redundant. And in this example, okay, we remove FAC. We remove member AC. We remove this AC as redundant. So redundant here is FAC. Redundant is FAC. So having this, so straight away we can get, so this is R1. So what we get is delta 1 naught plus F11 times FAC, which is equal to 0. So this will be the equation. Delta 1 naught plus F11 times redundant FAC is equal to 0. So for the compatibility equation. Okay, by inspection, the truss is indeterminate to the first degree, one redundant only. Okay, FAC is removed. Okay, so we apply principle of superposition, then we get compatibility equation. Compatibility equation. So we have we use R1 FAC, so we use 1. So we get like this 1 1. Okay, so what we need to do now is we have to get we have to get displacement from two systems, primary truss and redundant truss. Primary truss and redundant truss. So we should have one primary truss and one redundant FAC applied as redundant truss. So we have to remove redundant. We have to remove redundant. Okay, so we have to have a primary truss. So we have primary truss. Okay, this is primary truss. Okay, loading is 8.6. This is 8. Okay, let's say this is 8 meter. This is 6 meter. Okay, I change this to kilonewton. I change this to kilonewton. I put here 200 kilonewton. 200 kilonewton. So what we need to do, this is the primary truss. This is the primary truss. So in primary truss, we will determine N naught. We will determine N naught. So we have to calculate reaction. I have to calculate reaction. So by taking moment at, so we have A, B, C, D. Okay, by taking moment at A is equal to 0. So what we get is 200 times 6 minus dy times 8. So what we get is dy is equal to, it is 200 times 6 divided by 8. So this one is equal to 150. So dy is equal to 150. So automatically AY, we get negative 150. And we get AX, which is opposite, it is 200. Okay. Now, from this diagram, we will continue to calculate the member force in the primary truss and member force in the primary truss. The member force in the primary truss is like this. Okay, so we get this. This is 200. We get 150 here. We get 150 and we get 200. So what we should do is we should balance the loading at each joint. Okay, so we get here 150. We get here 200. We get here 200. And this one is 0. And then what we get? We get here 200, 150, and we get 200 and 150. So this is the moment, this is the member force or internal forces in the truss. Okay, so this one is 250. 250. 250. Okay, so this is for primary truss. This is for primary truss. So now we will move to redundant truss. We will move to redundant truss. We will move to, we will move to redundant truss. In redundant truss, the symbol is N1. Okay, the symbol is N1, redundant truss. So member force is redundant. Force in member AC is redundant. So we have this. Force in member AC is redundant. So we have to put a unit value of FAC like this. So this is A, B, C, and D. Okay, since force in member AC is internal force, so it means that there is no external force here. External force. So when there is no external force, no reaction. No reaction at the support. Means that here is 0. This one is 0. This one is also 0. So what we need to do to calculate the member forces N1 in this truss is we have to do some steps, including balancing. Okay, we have to resolve first and then balance and then find the value using trigonometry. Okay, so what we need to do is we have to resolve. Okay, we have to resolve and then we have to balance. 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 Balance again. No. One to the right, one to the left. One down, one up. One to the left, one to the right. One up, one down. Okay. So now what we need to do is we have to determine using trigonometry. Using trigonometry, what we have is this is 8, this is 6. So this is 10. Okay. So 1 is equivalent to 10. 0.6 is equivalent to 6. 0.8 is equivalent to 8. So what we get is all the vertical value is equal to 0.6. This is 0.6. This is 0.6. The horizontal value equal to 0.8. And the inclined value is equivalent to 1. Inclined value is equivalent to 1. 1. Okay, so this is the member force in redundant truss. Member force in redundant truss. So what we need to do is we have to substitute all this value, these two value into the table. Okay, we have to substitute into the table. So the table should have, because we know that the equation is delta 1 naught plus F11 FAC equal to 0. Equal to 0. And delta 1 naught is summation N1 N naught L over AE. And F11 equal to summation N1 N1 L over AE. N1 square over AE. So we should have the table which has column for N1 N naught L and N1 N1 L. So we create the table down here. So it should have member, length, and not, and 1, and 1 and not L, and 1 square L. And lastly is N. So 6, all 6 members, 7. Okay. So this is the table. The table consists of members. Okay, member. And then length for each member, length. And then we should have column for N1. We should have column for, N0 first, N0 for the primary truss, N0. We should have column for N1. We should have column for N1 and not L. We should have column for N1 and N1 square L and 1 square L and N. And N is the member forces in actual truss. Okay, this is the table to analyze truss. Okay, we should list all the members. We have AB, we have BC, we have CD, AB, BC, CD, AD. We have AD, AC, AC, as well as BD. Okay, L, AB is vertical is 6 meter. BC is horizontal is 8 meter. CD again 6 meter. AD is 8 meter. And this one is, another two is 10 meter, diagonal. Okay, so N naught. So we just take the value we get from this primary truss. So we get AB. Here is A, B, C, and D. AB is positive 150. AB is positive 150. 150 positive. BC is positive 200. Positive 200. CD is equal to 0. CD is equal to 0. AD is equal to 200 positive. 200 positive. AC is equal to 0. AC is equal to 0. BD is equal to negative 250. Negative 250. And then we move to N1 redundant system. We have AC is negative 0.6. Negative 0.6. Negative 0.6. Negative 0.6. We move to BC. BC is negative 0.8. Negative 0.8. CD is negative 0.6. Negative 0.6. AD negative 0.8. Negative 0.8. AC is 1. AC is positive 1. BD is positive 1. Okay, so we solve this. it is N1 N naught L. N1 N naught L is equal to 6 times 150 times 0.6. It is negative 540. Okay, 8 times 200 times 0.8, negative 1280. This one is 0. This one is 8 200 0.8 again, negative 1280. AC is 0, and this one is 10 times 250 is negative 2500. And 1 square, it is negative 0.6. 0.6 square times 6, we get 2.16. This is 2.16. Okay, next is 0.8. 0.8 times 8, we get 5.12. And then 0.6, 2.16 again, and then 0.8. 2.8 square times 8, we get 5.12, and then we get 10, and we get 10 as well. 10. Okay, now we have to find the total. We have to find the total. The total N1 N naught L is negative 540 minus 1280 minus 1280 minus 2500, and this is equal to negative 5600. Negative 5600, and for N1 square L, we get 2.16 plus 5.12 plus 2.16 plus 5.12 plus 10, so we get 3456. 34.56. So we have to substitute this into the compatibility equation. So it is delta 1 naught plus F11 times FAC is equal to 0. So it is negative 5600 over AE plus 34.56 over AE FAC. So this is equal to 0. So FAC is equal to 5600 divided by 34.56. So this is equal to 5600 divided by 34.56 equal to 162.04 kilonewton. Okay, so last step is we want to calculate. We want to calculate force in member force. Calculate member force. Member force in actual truss. Okay, by using the principle of superposition, we get N is equal to N naught plus N1 times FAC. So this is equal to N naught plus 162.0 for N1. Okay, this is the formula to get the final answer, which is member force in actual truss. 162.04 times N1 0.6 plus 160, so we get 62. This is 62.776. Okay, the second value again 162.04 times with N1 times negative 0.8 plus with 200. So this is 70.368. Okay, so another one, CD, it is 162.04 times with N1 negative 0.6. We get negative 97.224, and then we move to 162.04 times 0.8, negative 0.8 plus with 200, 70 and 368, and then 162, redundant is 162.04, 162.04, and then last value is 162.04, 162.04 times 1 minus 250. It is negative 87.96. Okay, so this is the end of analysis of trust, indeterminate trust. Whenever redundant is come from member force. Redundant is come from member force. Okay, so that's all for this session. So we will meet again in the next session. Thank you.